So we can start the webinar of today that is about cryptography in PHP, and I would like to spend some time about a subset of the cryptography that is the strong cryptography, and I will explain, of course, this terminology. My name is Enrico Zimwell. My email address is enrico@zen.com. So if you have also question for, because we have just 1 hour, so for sure we don't have the time to answer to all the questions of you. You can use my email address for future question and comment and feedback as well. I'm an engineer at Zen Technologies. This is the just one slide about me. I'm a software engineer since 1996. I'm using PHP since 1999, and starting from this year, I work for the Zen framework team. And today, I would like to, talk about cryptography because it was one of my previously topics of research and also for working previously to join Zen Technologies. So this is why I joined, I choose these topics for the webinar of today. And I have also a blog about PHP and programming, and this is the email address. Basically is my surname.it, where it is Italy because I'm Italian, /blog. So you can check out my blog for future topics. Okay, let's start the webinar. So for the question and answer, we will use the remaining time of my presentation. So what is strong cryptography? This is just a general definition about this terminology. So basically it's the usage of cryptographic systems or components that are considered high resistant to cryptanalytic attacks. So this is just the definition. So basically is a subset of the cryptography word, let me say, because the aim is to use basically strong, really secure from a cryptographic point of view algorithms. So the first question is, okay, of course we want to use the best technology as possible to protect our information, to use cryptography, but how we can be sure that are really secure? So the question is, exists a metric of security? So it's very difficult to answer to this question, and basically there is not a mathematical answer from this question. We have to consider three kinds of topics. So we have to consider the brute forcing attacks, theoretical attacks, and implementation attacks in order to understand, try to answer to the question if a cryptographic algorithm is real secure. Real secure, I mean in the real life. So basically what means brute forcing attacks is a kind of attacks that try to generate all the possible keys, all the possible way to encrypt information, to try to find the key, the secret information that you use it to encrypt your messages. So basically the brute forcing attacks is related to the technology that we are using, because for instance if we have a key that is very small, for instance 2 or 3 characters, it's very simple with a modern computer, with a modern CPU, to generate all the space key, all the possible key, and try to figure out what's the one that we use it to encrypt the information. So generally speaking, the space key is the size of the key is in byte or in bit. So for instance, if we have 128 bit, the space case is to power of 128 bits. So for sure we will see that in the modern cryptographic system we try to use key that are basically at least 256 bits. That's for historical reason, and also for because all the modern cryptographic system use basically this kind of space key. But we will talk later about the space key. Another possible attack is the theoretical attacks. So this kind of attacks comes basically from research, where mathematics and computer scientists try to understand, try to attack on cryptographic algorithm using the theory. And basically I will show you right now what are the best encryption algorithms. And for instance, there are always attacks on cryptographic algorithms. The AES, this Advanced Encryption Standard, is one of the most famous block cipher encryption algorithms. That is become a standard for the American people, and not just for American. The AES with the 256 bits, right now there are a couple of that try to reduce the number of key that we have to try. So basically, and as you can see in the slide, the recent attack can reduce the space key to 2 power, basically about 2 power of 100. And that means that this kind of attack is able to reduce by half, more than by half, the number of space key. But as you can imagine, 2 within the power of 100 is a very huge number, so it's quite impossible to provide a brute forcing attack using AES, even if there are some theoretical attacks. From a practical point of view, is considered secure, the AES algorithm. And the third kind of attacks, this is one of the most important, especially for security in the real life, is the implementation attacks. Because when we talk about cryptography, we talk about theory, we talk about algorithm, but we are engineers, so we have to implement this algorithm in a specific computer languages. And this is the step where problems comes out, because most of the attacks in the real life comes always by the implementation. So we have a lot of example with also a mistake in the implementation bug that can provide you, the rootkit, the way to bypass the security of a system. And in cryptography is quite the same. For instance, if you think about the Wi-Fi, the web algorithm that was used, that is still used in some Wi-Fi network to encrypt information, is not so secure for problems in the implementation of the algorithm, and also for the space key. For instance, one of the most famous cracking system for cryptography was the AFF desk cracker. Was named Deep Crack. Was a computer built by the Electronic Frontier Foundation in 1998 to perform a brute force search of this cipher's key space. So basically, in the 1998, this association, Electronic Frontier Foundation, figured out that the space key of the desk was not so good enough in order to to protect information, and they built a special computer with a lot of CPU, with parallel CPU, to decrypt a message encrypted with the DES cryptogram. And they figure out that basically they spent the average was about 56 hours of work to decrypt the information. So that's quite quite amazing, because we are talking about 1998, and so if you are using right now the DES algorithm, you feel that for sure you are not secure. That's the point. So as you can see, the security of a cryptographic system is always related to the technology that we are using. Because, for instance, if in the future we will have a quantum computer or whatever with incredible speed, for sure we have to re-implement, redesign our cryptographic algorithm. For sure we have to increase the number of the space key and so on. So it's always, I repeat, the security is always related to the technology that we have. Okay, some example of strong cryptographic algorithm. So right now are considered strong some algorithm like I say AES, Advanced Encryption Standard, Blowfish, Twofish, RSA, that is a public key encryption algorithm with key more than 2048 bits. And I gave also some example of software that use some of this algorithm. For instance, PGP, OpenPGP, and GroupPG are considered strong from a cryptographic point of view. Are not considered strong the DES, and I told you why. The WEP, the Wired Equivalent Privacy algorithm, that is used in Wi-Fi systems. The SSL with 40 bits, the international version, and basically all the classic ciphers like Enigma, Visionaire, and etc. Of course, this is just one slide with a couple of algorithms in cryptography that are considered secure. There are for sure more than this algorithm that are secure, that are strong, but these are just an example with one of the most used. The strong cryptography is not only related to encryption, because as you know we have also hashing algorithms. So the meaning of strong cryptography in the hashing is basically is used as difficult to guess. So an hashing algorithm is considered strong cryptography, so it's considered secure when it's difficult to guess the hash of a value with the input hash that generate the output of the function. Cryptography versus security. A lot of people think that if they use cryptography, the system that are building are secure by definition. That's absolutely not true, because cryptography does not mean security. Encryption is not enough. Security is a process, is not a product. This is a famous sentence of Bruce Schneier, that is one of the most important author about computer security. Cryptography is basically a guru of IT security, and especially in the last books of Bruce Schneier, in at least a couple of books, he cover again the meaning of cryptography that is completely different from security. So if you want to build a secure system, for sure cryptography is a very good tool, is a very good instrument, but we have to use in a right way. Otherwise the security of the system is absolutely not sure. Another enemy of security is the complexity. So there are no complex systems that are secure. Complexity is the worst enemy of security, and it always comes in the form of feature or option. This is another famous sentences of Bruce Schneier. So when you consider to build secure system, you have to consider to build simple system, where simple does not mean stupid. You can build very sophisticated systems that are simple in the in the chain of the system, in the steps of the system, but are not complex. So that's very, very important when you try to implement a system that's supposed to be secure. Okay, so after this couple of introduction slides, we focus our attention now on cryptography in PHP. So basically in PHP you have a couple of possibilities to use cryptography. We have the crypt function that is built in PHP engine, and we have a couple of extensions like mcrypt, hash, and OpenSSL that you can use to use the cryptographic algorithm, and I will show you how to use it. So basically the crypt function is a hash function, so please don't confuse crypt with encryption. It's just hashing function, and it supports strong cryptography because using this function you can use the bcrypt algorithm and the SHH, that is a famous hashing algorithm. And you can start to use the bcrypt using PHP 5.3, and if you are running a PHP 5.3.2 you can also use SHH with the crypt function. The mcrypt extension of PHP is an interface of the mcrypt library. It's a famous library for Unix Linux systems for encryption, which support a wide variety of block algorithms. In this slide there is a list of this algorithm. As you can see, we have the triple DES, that is a variant, a more secure variant of the DES. We have the blowfish, we have the Randall, that is basically the AES, the Advanced Encryption Standard, and so on. We have a lot of other algorithms also with exotic name like Serpent and whatever. We have another extension in PHP that we can use to hash basically a string file or whatever. The hash extension is enabled by default with PHP starting from PHP 5.1.2, and this extension replaces the old mhash extension. Also here we have a couple of possibilities. We have a lot of hash algorithms supported. We have MD5, MD4, SH1, and Tiger, Ghost, and whatever. So it's quite a good extension. And finally we have the OpenSSL extension that uses the function of the OpenSSL project. That is a famous open source project about cryptography to support the SSL and the TLS protocol. And we can use this extension even in this project even in PHP using the OpenSSL extension. One of the most important algorithms in this extension is the RSA algorithm. That is, I repeat, a public key algorithm, and I will show you a couple of examples in a couple of slides. So the suggestion is to use always standard algorithms. Don't try to create new encryption algorithm, because it's a very complicated work. You need a lot of mathematical background. You have to be an expert in order to produce a real encryption algorithm. So suggestion is use standard algorithm, like for instance AES, that is a real standard. I repeat, is used basically in almost all the software that use encryption today. So it's for sure one of the most recommended algorithms. Also the blowfish, the two fish that are also symmetric block cipher algorithms are quite good. And of course, if we are talking about public key encryption, RSH is for sure one of the most famous. And for the hash algorithm, I strongly suggest to use SHA with at least 256 block sites. So, some example and best practice in PHP. One of the most important question is, if you want to use cryptography in PHP, and if you want to use strong cryptography in PHP, how to build the key. Because as you know, the key is one of the most important aspects of encryption. Basically, the security of a system, of a cryptographic algorithm is strongly related to the security of the key. If you use standard cryptographic algorithm and you are able to secure the key, basically you guarantee the security of your system. I repeat, from a cryptographical point of view. So how to build a key in PHP? If you have to generate a new key, of course you can use a pseudo-random generator, and the suggestion is to use the OpenSSL random pseudo-bytes function. That is basically a function of the OpenSSL extension, and it comes with the PHP 5.3. And don't use rand or empty rand function, because they are not considered secure from a cryptographical point of view, because the quality of the pseudo or the random generator of these two functions are not enough in order to talk about strong cryptography. Of course, if you are using rand or empty rand for other topics that are not considered strong cryptographically secure, you can use it. There are a lot of examples of you using of the rand and empty rand function. If you want to generate a key for an encryption algorithm that comes from a user password, for instance, for sure the first suggestion is don't use the user password as the key of your encryption algorithm. So it's always better to use an hashing algorithm with a salt information, and I will show you an example, to generate, in order to start from the user password, hashing plus salt value, and the output use it as the key of the encryption algorithm. So you can also increase the security of the system with the iteration. So you can this is the technical term is stretching in cryptography. That basically means you have to iterate this using a loop, the hash with the salt, with the output using the input. So basically is a feedback. This basically is to prevent the using of hashing algorithm with the salt, is to prevent dictionary-based attacks, because it's quite simple to try to generate the hashing value for all the famous word password, like admin, like God, like love, and whatever. There is a list on internet of one of the 100 most famous password that people choose when you ask, tell me your password. And it's quite simple to generate basically a dictionary with all the hash value of this password. So this is why we use a salt. This is why we insert in the input of the hash algorithm a fixed string that is usually a random string, and we concatenate this string with the password with the user password. So it's very, very important to use a salt system. And if you want, you can try this website, md5.rednoise.com. that basically is a Google of hashing values. So you can put the hash value of your password to try to figure out if it is in the database of this website. How to generate pseudo-random key in PHP. Here there is an example of one function that uses OpenSSL random pseudo-bytes function to generate a pseudo-random key. If you are running the right PHP engine. But if you run this code with old PHP application, or legacy PHP application, less than PHP 5.3, you can basically you can see that we generate a pseudo-random key using the empty run, because this is the only opportunity that we have using the old version of the PHP engine. But we are using the SSH 256 algorithms, hashing algorithms, and basically the idea is to to generate the best pseudo-random starting from the empty round. So this is just I repeat an example that you can use to generate a pseudo-random key. So if we want to build a key from a user password, I repeat, we have to use the hash password with a random salt, and we can use a stretching, so we can loop, basically we can repeat the hashing n times. So here we have an example. So we start from salt, so we generate a pseudo random salt, and we store it in a $salt variable, and here we have a loop is for e starting from 0 to a limit that is a constant. So basically we generate an hashing of the hash that the first during the first step is empty, salt that is basically the pseudo-random salt information, and the password that is the password, the user password. And we iterate, we loop inside this $hash. So basically means that the second step we have the $hash, the previous output in the next input, and so on. So this basically is a simple loop, and but here we have a constant hash cycle limit. So how we can estimate how much cycle we need to run in order to provide a secure key? So this is depends on the CPU speed. For instance, in my laptop, that is an Intel Core 2. So I found that so basically the point is to spend some time, to generate a good password, a secure password. So you should take at least 200 milliseconds or maximum 1 second to generate it. So this hash cycle limit depends on the CPU speed, and on my machine I figure out that I need at least 20,000 times, the loop of 20,000 times to generate a secure password. So I took about half a second. So this is very important. A lot of people ask me, so why I have to spend huge amount of time to generate just a secure password? Because if someone wants to attack your system, he has to spend the same amount of time, and especially if an attacker try to generate all the possible space key, it took a lot of time to do that. So that's why you should spend at least this time to generate a secure password. We have another possibility to create, to store a password in PHP using the bcrypt algorithm, and we can use the crypt function in PHP that is basically an hashing function. And as you can see here, there is an example how to hash the password using the bcrypt. So we have basically a salt, and we use the crypt function with this let me say strange parameter, because basically this is the wrapper of the bcrypt implementation. So this $to $8 basically means that we want to use the bcrypt algorithm, and this is basically the way to secure an hash password. $cost is the base to logarithm of the iteration count of the blowfish that used in the bcrypt algorithm. These are technical details. And if you want to check if a password is valid or not, you can simply just compare the hash value with the output of the crypt function using the password that you are trying to check, and the hash value. So that's that you store in a somewhere, for instance, in a database. So as you can see, it's very simple to check if the password that the user is trying to use to authenticate in your system is the right one or not. You can do the same basically using instead of the bcrypt, using for instance a SHA algorithm, and here we are using basically the same idea of salt and stretching. So we have a loop, and we are just looping inside the hashing of the salt, reusing the previous results in the $hash. But we will share the slide so you can see the details without problem. Okay, so another example, how to encrypt using the advanced encryption standard with the key of 256 bits. So basically here we are using the mcrypt extension. So we have to previously generate one information that is named EV, and I will explain later what the meaning of this EV. Right now it's just a parameter of this encryption. So we have to first generate the size of this EV according to the type of the algorithm and the mode of the algorithm, that is the CBC. So we have to create after the IV using the mcrypt rand, that is a constant. That means basically we want to use random IV. We generate the key. In this example we have a pseudo-random key. This is the function that I showed you previously in a couple of slides. So we are, because we want to use the AES with key of 256 bits, we have to use 32 bytes basically. So we want to generate a pseudo-random key of 32 bytes, and this is the function, the mcrypt function, to encrypt the data, because the data are basically the plain text that we want to, the message, the file, whatever that we want to encrypt. So as you can see, we have just to use the mcrypt underscore encrypt function, using where we specify the type of the algorithm, that is for the AES is the Randall, with the block size of 128 bit, because the AES is a blocked block cipher with 128 bits. The key, we have the key, we have the plain text that we want to encrypt, the string that we want to encrypt, we have the mode, that is the CBC, and we have this IV. So it's very simple. To decrypt, we have a symmetric function that is mcrypt underscore decrypt, and basically we use the same parameters. Of course we have to use the encrypted string in order to decrypt. So basically the question here is, what is the IV, the $IV? The $IV, the IV in general, is the initialization vector. That is basically a parameter for the encryption algorithm, and is a fixed size input that you have to use, generally speaking, in a cryptographic block cipher algorithm, and required to be random or pseudo-random. The IV is not a secret. That is very, very important. A lot of people think that they have to store in a secure way the IV. No, that's not true. It's not a secret. You can send it in plain text. So usually the IV is stored before the encrypted message and sent with the message. So in order to understand why IV is not a secret, you have to go inside the detail of the algorithm, but basically the IV is just a salt for the encryption algorithm to work better. That's the point. So especially if you provide an initialization vector IV that is random, or at least pseudo-random, and you change every time you encrypt your data, that is the best solution to be sure that your encryption algorithms works fine. In this slide there is a block diagram where basically I show you what is the CBC modes. That is one of the most used mode for encryption algorithm. So basically, as you can see, we have starting from the top to the bottom, we have the plain text. So basically we have the message that we want to encrypt. This message is divided into some block, because this encryption algorithms works in a block cipher, so they just work on a fixed size of block of bits. So we have, for instance, the first block, we have the plain text, and we have the IV, the initialization vector, and we have this operation that is XOR. So basically we XOR the plain text with the IV, and here you can start to understand why it's important that the IV should be random. And the results is used inside a block cipher, for instance AES, Blowfish, or whatever, using the key. And the output is the first block of the ciphertext. This block is reused in the second part, in the second step of the algorithm, again using the plain text. So we XOR the plain text with the results of the previous, of the first step, and so on. So as you can see, this is basically a loop inside the blocks, the size of the input basically. And we collect at the end of the block, we concatenate all the block, and this is the ciphertext, the output of our encryption algorithm. I repeat, this is just an example of how CBC works. CBC, I repeat, is a type, a mode type, operation type of an encryption algorithm, and this is one of the most used. Okay, we jump very briefly into another topic that is quite important in order to understand the OpenSSL extension. That is the public key cryptography. So I don't know if you are familiar with this topic. I just collected a couple of slides just to explain the very background, the very basic knowledge about the public key cryptography. So basically the idea is to use an encryption algorithm that uses two different keys, one to encrypt and another to decrypt. So we have an example. We want to encrypt a message. So we have the plain text message, the unencrypted message, and we want to use we want to send this message to a receiver. So we just use the public key of the receiver that are public, so everyone can use it as the key for the algorithm. And we use an algorithm, a public key cryptographic algorithm, for instance RSA, using the receiver public key. The output is the encrypted message, so we can send this message on an unsecure channel, for instance like internet, as an email, and when the receiver receives the encrypted message, he can use the private key of the receiver to decrypt the message to obtain the plain text. So that's the idea. Basically, the sender uses the public key to encrypt, and the receiver uses the private key of the receiver to decrypt the information. And of course, the private key is private, so it should be stored in a secure way and not shared with everyone. The public key you can share with whatever you want. The good part of the public key cryptography is that it's used not only to encrypt information but also to authenticate a message. So here there is an example how to do that. So basically the idea is to reverse the previous slides. So instead of using the public key of the receiver to protect information, we use the private key of the sender, because here the goal is to authenticate the message. So we want to be sure that the message comes from the real sender. So basically we have an example how to generate a message digest. This is a more complicated example. So basically we start from a message, we generate an hash of this message using, for instance, an hashing algorithm like SSH with 512 bits, and we use the sender private key to encrypt this message. Sorry, not to encrypt the message, to encrypt the hash, the message digest. So basically this is the procedure to obtain a digital sign. And when the receiver basically receive the encrypted message digest, you can use the sender public key to be sure that basically the output is the same of the message. So the message is, in this example, is sent in plain text, so it's not encrypted. So everyone can, starting from a message, generate the hash value, and the output is compared with the output of the encryption algorithm. If are equal, that means that the message was transmitted correctly and comes from the original sender. If no, if the message digests are not the same, that means that someone has changed the message during the transmission. So is also a way to to obtain integration of messages. This is, I repeat, just an example of how the public key cryptography can offer to us a lot of opportunity to use very good implementation for secure messages and for authenticate. Okay, let's go back to PHP. How to use public key cryptography in PHP. We have the OpenSSL extension. So of course we have to generate the public key and the private key. So we have to use the OpenSSL pkey new function to generate a new public and private key. In this example, we are using the algorithm RSA, and we are generating key with 2048 bits. We can use the export to file function to store basically this private and public key in a file, and we can of course get the private key, the detail of the key, using the OpenSSL pk get details. Okay, when we generate the public and the private key, we can use it to encrypt or to decrypt information using the public key cryptography. And in this example, we are encrypt some information using the public key file, of course, of the receiver. So we can use the OpenSSL public encrypt. We have just to pass the plain text, the encrypted, and the public key, where encrypted is the output basically of this function. So also here the API of this OpenSSL are not so good, but they work. So just be sure that the $encrypt is the output, is the variable where the OpenSSL encrypt store the encrypted message. And in order to decrypt, of course, you have to so basically this is the same idea of the first diagram that I show you. So to decrypt, you have to use the private key. So you have here the private key file with the passphrase, where passphrase is just a password to open this file. This is a more secure system, to prevent that someone copy the private key and use it. So you have to know the file and the passphrase to be able to open the private key, to use it, the private key. And we have the same basically as for the encrypt. We have the decrypt function in the OpenSSL private decrypt, and the API is quite the same. So that's just I repeat, an example of how to use RSH using PHP. Public key cryptography to encrypt data. So this is another scenario. So we want to use the public key cryptography to encrypt data. So we don't want to use the block cipher, but we want to use an algorithm like RSA, for instance. In general, the public key cryptography is not used directly to encrypt data. Why? Because public key cryptography, the algorithms are computationally heavy. That means that the algorithms are very slow. So you cannot use an RSH algorithm to encrypt 1 gigabyte of data, for instance. It's not possible. you have to use the hybrid systems. That means public key plus block cipher. And I will show you a very famous example, that is the PGP. PGP is a free software to to protect messages, information, emails, whatever, using public key cryptography. So basically the idea is to use a block cipher to encrypt the plain text, generate a session key that is random, and just secure this session key using the receiver public key. So the RSH algorithm is used just to encrypt, to secure the key, the session key that we are using when we send the message. And of course this is a key, so the information is very is not so long, so the RSH algorithm works perfectly fine, and the result is an encrypted session key that is sent together, concatenate together with the ciphertext, and this message is sent to the receiver. When the receiver gets the message, so basically you can use the is private key to decrypt the information, to decrypt the session key, and decrypt the ciphertext using the block cipher and the session key. So it's quite simple, but basically that's the idea. So we use public key, we are using RSH in this example, plus block cipher, for instance AES, blowfish, to fish, or whatever. So it's very simple diagram, but very powerful, and a lot of systems basically are founded on this diagram. Okay, so basically I complete my presentation. I have here some resources, some books and papers that I used to build this presentation, and I collected also a couple of web references, resources, so you can check it out when you will see the slides published on the zen.com website. Okay, so that's it. Let's start. We have 10 minutes for question and answer. Okay, so we have a question coming from Bart about the duplicate hashes. So the question is, for instance, when I hash my password of 20 100 times, how I'm sure that the outcome hash does not equal to the hash of any other simple string? That's a very good question. So basically this comes from the theory, is a mathematical property of the hash algorithm. So if you are using, for instance, SSH, the probability to have this kind of scenario is very low. And when I say very low, I'm saying something like 0.0000 about I don't remember right now the right amount of probability, but I can tell you that it's very low. So it's up to the the quality of the hash algorithm that you are using, because the stretching is, of course, is a general methodology in cryptography, so it's up to the hash function. So let's go to another topic, another question. I heard this is a question come from Dominic. I heard base 64 encode was more than sufficient in most instances. Is that not true? Base 64 is a coding system that is used in cryptography because it's one of the most simple and one of the most general. So usually when you encrypt information and you want to be sure that the receiver has not problem with the encoding system, hash values and whatever, so it's general. You encode the output of an encrypted message in basic 64. Especially if you have to store the information, if you have to pass information from one server to another with different operating system, different languages, is always using base 64. Okay, we have another question coming from Dragos. Do you know if there are common crypt functions between PHP and JavaScript? I mean, I would like to encrypt a message from JavaScript some users submit info and decrypt it on the server side. So generally speaking, there are a lot of function also in JavaScript, but from a security point of view, JavaScript is a client-side. If you are talking about, of course, web application, is a client-side computer languages, so it's not considered secure by default, because you are not the owner of the code, basically, of the how can I say, of the system that run the code. So generally speaking, it's always better to trust in a server-side system, like for instance PHP, and try to do the job to PHP. So my suggestion is to use always PHP as language from server side to encrypt, decrypt information. Of course, you can think about different scenario using JavaScript and web services. So it's quite this is quite common to use just web services on PHP to encrypt and decrypt information. This question comes from Thomas. It's not overkill to use encryption keys that are larger than 128 bits. No. Also here depends on the answer is related to the encryption algorithm that we are using. And my suggestion is to try to, if you want to implement a real secure system, you should always try to use the best technology that you have. So for instance, if you are running PHP 5.3, if you want to be sure that your encryption algorithm works fine, let's try to use the maximum key size that you can. So for block cipher, at least 256 bits. I know that is that is not so good from a performance point of view, but there is always a balance between security and performance. So if you want to build a secure system, you don't care about performance. That's the point. Because if you care about performance, I can say that you are not you are not building a real secure system. When real, I mean from a cryptographic point of view. So let's always, my suggestion, try to use the best technology that you have. Okay, we have a question coming from Brett. What hashing method will you recommend for storing password using PHP 5.2? My first suggestion is to try to use PHP 5.3. Okay, I'm joking, but if this is not possible, so if you have to use PHP 5.2, so you can use basically the SSH and the stretching and salt algorithm in the as in the slide that I presented. So that's the best approach. Oh, this is a question about performance. A question about Brian. Is there much of performance differences between PHP and other languages such as Java? I mean, I don't have an answer from that. For sure, PHP is considered one of the fastest languages, especially for deploy web application, and especially in the cryptographic extension that I presented. So for instance, the hash, the mcrypt, so basically are just developer of the mcrypt library, so it are very fast. I repeat, I don't have a real answer comparing with the other computer languages. Okay, we have a question from Laurent. What is your advice for encrypting big files, several gigabytes, on a file system to store them securely? Okay, this is a very good question. So the general, from a cryptographic point of view, my suggestion is to use a block cipher with the CBC mode. But for sure, you can also, starting to investigate using different approach. But I repeat, from a cryptographic point of view, that's the most used one. So block cipher with CBC mode. Okay, this is a question from Chris. Can we use SSH 512-bit to encrypt a password and use SSL for the rest of the data on the site. Is that secure enough? I mean, it's not, I repeat, security is a process, so it's not a system, it's not related only on technology, but for sure, if you use in your system, in your software, SSH as hashing algorithm with a key, with a block size of 512 bits, and you use SSL, from a technical point of view, you are using the right, the right tools. But of course, you have also use it in a right way. But I repeat, from a technology point of view, are the best technology that we have right now. So the answer is yes. So I think we almost sorry if we don't have time to answer to all the questions. So if you still have other question, you can send me an email. I repeat my email address, that is enrico@zend.com. So thank you to everyone. Bye bye.